Hello. In this video, we're going to look at a really interesting example of logarithms and compound interest. So what if instead of saving your money and just leaving it, you kept adding to it every month? Say you deposit $100 into a savings account at the end of every year. The interest rate is 6% compounded annually. How much will you have in 5 years? Now, this is really interesting because before, in our previous examples, we've just taken our $100 and left it in the account for 5 years and we see what happens. But now we get to add to it. And so how do we calculate this as the money goes in and then it gets compounded, goes in, gets compounded? The easiest way is to just step through it one at a time. So because our $100 is invested at the end of each year, we can sort of write it down like this. So this is the start, and then this is going to be after 1 year, then after, I guess, 2 years, and then 3 years, and then 4 years, and then 5 years. So we're going to go through the whole process here. So at the start, we have nothing, 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 and then at the end of 1 year, we add $100. So now we got $100 in here. All right, another year goes by. At the end of 2 years, we're going to get interest on that $100. So times by 1.06, and we'll have $106. And we add another $100, so now we have 106 plus 100, so 206. Okay, we're going to go over here to 3 years, and so another year goes by. That $206 generates interest for us, so 206 times 106. And that's going to give us $218.36. But it's the end of another year, so we add another $100. So that's going to give us $318.36. Another year goes by, so we got to take that and multiply by another 1.06. That's going to give us $337.46 with some more decimals. We add another $100 because it's the end of the year. Very happy that our money is growing so much. Now we go through another year. We get another round of interest. So we get to multiply this by 1.06. $463.71. And then we add another $100 at the end of that 5th year, giving us a grand total of $563.71. Now, a few things to mention about this. First thing, the number should make sense, right? We've been doing this for 5 years. Each time we've done $100, so 5 times 100 is 500. So if you were not getting any interest, you would expect there to be $500 in your savings account. In fact, there's $563, so we can see that we've done the calculations probably correct. I mean, we have a little bit more than 500. We've got some interest, makes sense. And the amount of interest we've got is more than if we had just done $100. Because if we had $100 and we had done that for 5 years, that would be 100 times 1.06 to the power of 5. Okay, so that would be giving you compound interest on just that initial $100. If we had done that, we would have gotten $133 and then some cents. So that would have given us $33 in interest. We actually got $63 in interest. So it's more than what you would have gotten on just the initial $100 because you get interest on the 100, but then you also get interest on the other hundreds that you keep adding to your bank account. So kind of an interesting process, but if you look, it's kind of crazy, right? There's all sorts of numbers. I've got these arrows, there's these years, and it feels like it's hard to keep track of. And honestly, it feels like it'd be pretty easy to make a mistake. So the question is there a way to do this faster? Is there a way to compact all these steps into some kind of formula? Have mathematicians created a formula for this kind of question? And of course, the answer is they have. So this is called the future value formula. The future value of your investment is equal to R, the regular investment amount, big bracket, 1 plus I to the power of n minus 1 divided by I. Now, I never said this would be an easy formula because that wasn't an easy process. But there is a formula to give us our values. Let's go ahead and see if it works. R is $100. That's how much we were investing. The number of investments was 5. The future value, we're pretty sure, was 563.71, but we'll want to check that in the formula. And the interest rate was 6% per compounding period. So it was 6% compounded annually. So as a decimal, we could write that as 0.06. So we write down 100, big bracket, little bracket, 1 plus 0.06 to the 5 minus 1, close bracket, divided by 0.06. Now we want to be really careful as we type this in on our calculator, keeping all the proper brackets involved. And if you do that, you should get a really nice number. So I encourage you, go ahead and pause the video, type it in, and see what your calculator gives you. If you typed it in correctly, you should get 563.709296, which rounds to 563.71. All right, we got ourselves the same answer as before. And while the formula might look a little complicated, it's a lot cleaner than trying to track all these numbers with the years and the interest and the additional payments. So I, for one, am very happy that this formula was invented. It makes doing these calculations a whole lot easier. So let's go ahead and try it on a few different questions. All right, let's say each month you deposit $25 into a savings account. You're going to get an annual interest rate of 7% compounded monthly. How much money will you have after 8 years? Now, the formula is a little bit tricky in this case. We're looking for, and I'll write down the formula again so we have it here. We've got R, 1 plus I, to the n minus 1 over I. So we're looking for some different numbers to plug in here. We're looking for R. I think that's pretty clear. It's $25. We're looking for I. That's going to be the interest rate, 0.07, but it's got to be per compounding period. And because it's compounded per month, we have to divide by 12. Now I'm going to tell you right away on your calculator, that's going to give you some ugly decimal. And so please just either leave it as a fraction or leave it as the exact value on your calculator. Don't go rounding. I mention this all the time. If we round early, we're going to get the wrong answer. Now, N is the number of investments. And because we're doing it monthly, and there's 8 years, N is going to be 8 times 12. So you got to do a little bit of math ahead of time. That's going to be 96. It's not the pure number of years. It's actually the number of investments that you're making. And since you invest once a month, and there's 12 months in a year, you get that 8 times 12, or 96. Okay, so 25, 1 plus I, which is 0.07 over 12. That's 7 over 1200 to the 96 minus 1 divided by 7 over 1200. Now again, please be very careful as you type this in on your calculator. Now we want to make sure that all the brackets are right, all the fractions are typed in properly, and assuming that you type it in correctly, you should get the following number. $3,204.97. All right, so that's the basic version of this question. That's where we're looking for the future value. So we know the amount we're depositing, we know the interest rate, we know the time, we're looking for the future value. But obviously we can change up this question a little bit and we can ask different versions. So what I think is kind of fun is to say, we know we want $30,000. Maybe we're planning to buy a new car. We're going to get an annual interest rate of 17%. Ooh, that sounds pretty juicy. It's compounded monthly, okay? And we planned to do this for 5 years. How much do we need to invest per month? So again, we know the interest rate. We know we want that car in 5 years, and we know the car is going to cost us $30,000. The question is, how much should we be saving per month right now? So we go ahead and set it up like this. $30,000 is our future value. R is our payments. We don't know how much we should be investing. 1 plus the interest rate is 0.17 over 12. N is 5 times 12, which is 60. So we're doing 60 investments. Divided by 0.17 over 12. Now the goal here is to solve for R. We need to find a way to solve for the r in this equation. And I encourage you to pause the video and give it a try. Okay, the basic thing you need to do here is take all this and turn it into some number, because we're going to need to divide both sides by whatever this number is, and then we can solve for r. So it's actually only a one step of algebra, but it's a lot of steps of calculator. So let's see what we get on that right side. So you should get, let me just erase it so we can actually put the number. You should get 93.58118,159. And so we divide both sides by this number. And the easiest way on your calculator is to type in the 30,000 and hit divided by the answer button, ANS. That way your calculator pulls all the decimals, you don't have to write them all down. So when you do that, 30,000 divided by your answer, it should give you r equals 320.577. Now again, this is a little technicality. Normally, I always say in pre-cal go to 3 decimal places, but we're talking about money here, so technically you only go to 2, because we only go to 2 decimal places in money. So the answer is 32058. Let's include that dollar sign, and we only go 2 decimal places because it's money. So this is, again, an interesting result. If you save just over $300 a month, suddenly you'll have $30,000 for your car in just 5 years. Pretty interesting. All right, let's add another twist. Each month, Raj deposits $50 into a savings account with an annual interest rate of 8% compounded monthly. Eventually, Raj checks his account and notices that he has $9,147. How long did it take? So we set it up as 914730 equals 50. We know their payments are $50. 1 plus 0.08 divided by 12 to the power of n, because we don't know how long it's been. All divided by 0.08 over 12. Now the goal in this equation is to solve for the n, and it's definitely a tough one. I would encourage you to pause the video and give it a try, see if you can isolate for that n. All right, the first step I would do is probably clear this. This is pretty gross, and I think if we multiply both sides by 0.08 over 12, so multiply that over here, multiply that over here, at least it'll get the fraction out of the way. So we have 914730 times 0.08 over 12. Now, if you have the Mr. Peters approved calculator, this will give you a fraction, which is very nice. The decimal is not too bad. It's 60.982, but I always like leaving things as fractions because then I don't have any rounding issues at all. I'm not worried about having a rounding mistake. So then here I'd have 50, 1 plus 0.08 over 12 to the n minus 1. All right, next step, let's divide out that 50. So on our calculator, we should get, well, I guess it goes to a decimal right now, but it looks like it's not repeating, so that's good. And then on the left side, 1 plus 0.08 over 12 to the n minus 1. Now we've got that pesky minus 1 there. So to get rid of that, we should add 1 to both sides. That's going to give us 2.21964 equals 1 plus 0.08 over 12 to the n. Now the only way to get that n out of there is with a log. Remember, this is just like the last time. We want to take log of both sides, and that's going to allow that n to drop down. So you have n log 1 plus 0.08 over 12 log 2.21964. All right, the last step is going to be to divide out all the stuff in front of the n, or behind the n in this case. So you get log of 2.21964 divided by log 1 plus 0.08 over 12. All right, so be very careful, type all this in, and let's see what we get. N equals 119.9999841. So if we round to 3 decimal places, it's actually going to be a nice whole number. N equals 120 months because we are depositing every month. So it looks like Raj has been depositing for 120 months. If you wanted to convert that into years, you would divide it by 12, and that means he's been making deposits for 10 years. Now again, this is sort of the hardest version of the question, because if you want to solve for the future value of the investment, you simply plug everything into the formula. If you want to solve for the payments, you plug everything in and just divide out by this term. But if you want to solve for the time, which is the trickiest part, you have to do all this algebra with the logs, and you have to be very careful to keep all the decimals and do everything right on your calculator. So this is the toughest one, solving for time. And let's go ahead and do it again. So this time we're going to deposit $65, annual interest rate of 6.5 compounded monthly. He's going to have this much money. How long did it take? So please pause the video and give it a try. All right, so let's set it up. 3721.18 equals 65. 1 plus 0.065 over 12. Now again, if that works out nicely as as a decimal or as a fraction, you're welcome to use it. But on my calculator, it gives me 0.005416 repeating. And if you've got any kind of repeating decimals, anything that looks really ugly, just leave it. Don't risk rounding and getting a rounding error. All divided by 0.065 over 12. Again, we take this, convert it to a decimal by dividing by 100, and then we have to divide it by 12 because it's per compounding period. If you had a bit of a problem with the setup, you can pause the video now and see if you can finish it off from here. Okay, so I'm going to go ahead and multiply both sides by this fraction. Maybe I'll do it on the other side here. 0.065 over 12. Okay, so that's going to give me here 20.156 and so on equals 65. 1 plus 0.065 over 12. To the n minus 1. Then I'm going to divide by 65. So that's going to give me 0.310098 and so on equals 1 plus 0.065 over 12 to the n minus 1 plus 1 to both sides. So I get 1.310098 and so on equals 1 plus 0.065. Oh, make sure we don't lose a 0 there. Then I'm going to log both sides. So that's going to give me log of this really large number. So I'm probably going to need the answer key on my calculator. And that's going to have to be divided by log of 1 plus 0.065 over 12. That's going to be n equals. So here you can type in log answer on your calculator to pull the previous answer. Then you can type log 1 plus 0.065 over 12. It equals, and n should be 49.99995. So n is 50 months. N is 50 months. All right, so hopefully you're able to get that number. Again, I know it's a little tricky with the calculator work, especially following through all the decimals, but as long as you just don't round and keep everything there, it should work out nicely in the end. We'll go ahead and take some notes on this. So this is using logs on complicated money formulas. And you could imagine using logs to solve complicated any formulas, whether they're a money formula or something else. Whenever you have some formula where you have stuff equals other stuff, and you end up with your variable up in the exponent, right? The variable is up in the exponent. That's when you always need logs. Always need to take log of both sides. As long as you do that, everything should work out, even though the algebra might be a little tough. Now for our last example here, I want to ask the question everybody's been dying to know. How do you become a millionaire? Right? Everybody wants to become a millionaire. How do you become a millionaire? And that seems like the kind of question we could answer with our math. We want to have $100,000 as our future value. I mean, we could do either the easy version or the hard version. The hard version is probably what we should do, since this is the one with logarithms, which means we don't know how long it's going to take. But we know that we can invest a certain amount per month. Let's just say you do 150. That feels like a reasonable monthly investment. It's nothing crazy expensive, right? Some people spend 150 a month on their cell phone. But it's also not nothing. If you're going to become a millionaire, you got to make some sacrifices. You can't be putting away $5 a month and hoping to become a millionaire. So let's do something conservative, just $150 a month, kind of like an expensive cell phone bill. Now, we're going to be aggressive with our investments, and we're going to get 9% interest. So we're going to get 9% interest compounded monthly. We don't know how long this is going to take, so we're going to put an N up there, and then we'll get our 9% down here. So your goal is to solve for N, so go ahead and pause the video and give it a try. All right, so the first thing we're going to do is clear this by cross-multiplying it over here, or multiplying both sides. And when you do that, you should get 7,500 equals 151 plus 0.09 over 12 to the n minus 1. Now we can divide by 150, and that's kind of nice. Becoming a millionaire is involving a lot of whole numbers, which is pretty sweet. Got to move that 1 over, so we get 51 equals 1 plus 0.09 over 12 to the n. Running out of space here, so I'm just going to continue on. We're going to log both sides. Log 51 equals log 1 plus 0.09 over 12 to the n. Going to pop that n down. Again, the beauty of logarithms is they allow you to take those exponents and bring them down. That's in many ways why they were invented. They help us solve these tricky problems where you have your exponent as a variable. Divide out the log 1 plus 0.09 over 12. So n equals 526.206. Now again, we said we wanted to be a millionaire. So if we only did 526 investments, we would be slightly under $1 million, and that's no good. So because we want to be a millionaire, we have to go up. We have to go up to the next whole number, which means we need to make a total of 527 investments. So it's going to take 527 months, which if you took that and divided it by 12, because most people don't think in months, this would be 43.916, so almost 44 years. Now again, imagine you are 18 watching this video. 18 plus 44 years means that you will be 62 years old. So you won't even be 65 yet. You won't even be retired, and you'll be a millionaire. And that's what I've been trying to communicate. If you want to become a millionaire, it's actually very simple. You take $150 a month, which is kind of like a cell phone bill. You put it in an investment where you make 9%, which is, again, something you can talk to your bank about. You keep doing that every month, and you don't touch it, you don't take it out, you don't go on a vacation, you just leave that money and let it grow. You let it grow for 44 years, and by the time you turn 62, you're a millionaire. It's not flashy, it's not exciting, this isn't the kind of side hustle or YouTube video that's going to get a lot of money, a lot of views, a lot of clicks, right? This is kind of boring. It's just kind of basic advice, but honestly, this is how you do it. This is how you become a millionaire. You just take a little bit of money every month, you invest it faithfully, you do that for 44 years, and the magic of compound interest will generate more money than you could ever imagine. So again, I would encourage you, think about this, think about investing, think about the long-term growth, right? Short-term things, they kind of sound like get-rich-quick schemes. They're not usually legit, but this is legit. And if you don't believe me, Google it, go read some stuff, do your own research. But this is the basics. This is the math. This is how investing works, and it's quite cool, quite interesting. So again, if you want some more practice for this, you can look at Unit 9, Worksheet number 10, and write down some things to remember. All right, hopefully you enjoyed this video, and as always, thanks for watching.